Bismillah ar-Rahman ar-Rahim. So in the last lecture, we covered how to convert from any base to decimal, as well as convert from decimal to any base for the integer case. Today, we are going to continue and discussing this conversion, which is from decimal to any base for the fractions case. Okay, algorithm is simple. Okay, so we keep multiplying the fraction by the target base, and collect the integer parts each time of the answer. Okay, and we stop when the fraction becomes 0. This is best illustrated by an example. Okay, so let's see an example. Okay, so we would like to convert 0.625, okay, in decimal to binary. So what is our target base here? It's 2, right? So we keep multiplying the fraction by 2. So we start with 0.625 times 2 is 1.25, okay? So now the which is the integer part will form the answer, okay, for us. Okay, the fraction, okay, you take it and consider it as your new fraction. So you take the 0.25, okay, and put it here, okay, and then multiply it by 2 again. Okay, then you take the integer part, okay, and then you take the fractional part again, okay, and place it here and multiply it by 2. Okay, so you get an integer part and a fraction part. Now notice that the fraction part for the third step is 0. So here we can stop. Okay, we know that the process is over. Okay, so what is my number in binary that is equivalent to 625.625 in decimal? It is basically 101. So we start collecting the digits from the top here. We imagine there is a decimal point on the top, okay, or a binary point on the top, in fact, and then the digits are 1, 0, 1. Okay, so this is how to convert from decimal to binary, okay, in a decimal fraction to binary fraction. Okay, we stop when we get a fraction of 0.0. Okay, or we stop when something is repeating. We cannot continue to infinity, right? Or we stop when we satisfy the question requirement. For example, if the question says convert up to 3 digits after the decimal point, then we stop at the third step. Okay, so here is another example. We would like to convert 0.5 in decimal to base 7. Okay, base 7 is not octal. Octal is base 8. Okay, base 7 is something else. Okay, it's not a standard base. Okay, so you keep multiplying. Now we take 0.5 and then multiply it by 7, which is the target base. We get 3.5. Okay, then we take the 0.5 again, okay, and put it here again, and then multiply it by 7. We get 3.5, and you see that this is going to repeat. Okay, so 0.5 in decimal, okay, is going to be equal to 0.3333, etc. Okay, infinite number of threes. Okay, in base 7. Okay, so if the question says approximate your answer to 3 digits after the radix point, then this is the answer. It's 0.333 base 7. Otherwise, you can say, well, 0.5 in decimal is equal to 0.3, and then you put a bar on top of 3 to indicate that it is repeating. Okay, in base 7. Okay? Is that clear? Guys, did you leave already, or are you following, or what?
Are following it.
Yeah, it's clear.
Okay. Glad that I didn't hear any voice so far. Okay. Either the subject is easy or you're not following. Okay. I hope it's the first one. Inshallah. Okay. So let's take another example. So if you have a number, a decimal that contains both fraction and integer at the same time, then what to do? You split. Okay. You split the case. Okay. For the integer, and then the fraction, and then you combine again, okay? So you say, well, here 253.1 in decimal, we would like to convert it to hexadecimal. So we start with the integer, okay? So we convert 253 to hexadecimal by dividing. So 253 divided by 16 is equal to 15 with a remainder of 13, okay? And then we take the 15 and divide it by 16, okay, to get a 0 with a remainder of 15. So 13 is D and 15 is F. So we collect the digits this way in case of integer, okay? So imagine that the point is here as well. Decimal point is here, okay? Or the hexadecimal point is here. So this is going to be the maximum, since the result is integer, then this must be the least significant bit, and this must be the most significant, or the least significant digit, and the most significant digit. Okay, this must be the most significant digit. Okay. So what is the answer here for the decimal? It's 253 in decimal is equal to FD in hexadecimal. Okay. For the fraction, you take the 0.1 and convert it to hexadecimal. Okay. What does this? So you take 0.1 and multiply it by 16. You get 1.6. Okay. And then you take 0.6, which is the new fraction, and multiply it by 16 to get 9.6. Okay. And then you take 0.6 again, multiply it by 16 to get 9.6, and this repeats forever. Okay. So the answer here is 0.1 in decimal is equal to 0.19 with an over bar, the bar over the 9 in base 16. Okay. All right. So the final answer to this question is 253.1 in decimal is equal to FD.199, 999, etc. Okay, in hexadecimal. Okay, is this clear?
Yes.
Yes.
Okay. Well, moving on. So this is an exam question, okay, which is a tricky question. And not many students solved this exam, this question during the exam. So pay attention to this question, and hopefully you'll be able to solve it, okay, yourself. So we are given here, by the way, you should relate to this. This relates to all the material that we have covered so far. Okay, so do not limit it to the material that we just covered. Okay, so given D0, D1, D2 are integers between 0 and 15, including 0 and 15. So they are from 0 up to 15, including 0 and 15. We would like to find their values that satisfy this equation. Okay, D0 plus 16 D1 plus 256 D2 is equal to 2049 in of course in decimal. Any number that is baseless is in decimal here. Okay, so who can give me a hint on how to solve this? what can we let's say guess from this piece of information? The numbers D1, D0, D2 are
Doctor, we
yeah.
choose one of the D's to be 0, and we solve for the other D.
That doesn't guarantee the solution, no. But let's start baby steps. Now 0 to 15, what does it tell you?
Hexadecimal. So
Yeah, these are hexadecimal digits, right? So hexadecimal digit on the left hand side that are multiplied by some numbers is equal to a decimal number. What is this? A conversion from hexadecimal to decimal, right? So for the conversion, what do we use? We use this formula here. Summation of DI multiplied by 16 to the I. But hold on. Here we have 16 to the power 0. Fine. This is good. Here we have 16 to the power 1. But this is 256. What is 256?
16 to the power 2.
Excellent. Yeah, it is 16. So I goes from 0 to 2. So this is exactly a hexadecimal to decimal conversion. Okay? Or a decimal to hexadecimal conversion. We would like to know the digits of the hexadecimal number that has the decimal equivalent of 2049. Okay? So how do we solve this? We convert 2049 to hexadecimal, right? So how to do that? Who can remind me of the procedure?
Divide by 16 and look
Excellent.
for the remainder.
Yeah, we divide. So 2049 by 16, okay, is, we need to divide it by 16, 2049 by 16. Okay, here we have 1, 16, and then 4, and then 4. So here we have 2, 32, and then we have 12, and then we pull down the 9, and then we have 8 times 16 is 128, okay, and the remainder is 1. Okay, so the answer here is 128 with, this is the quotient, and this is the remainder. The remainder is 1. Okay, so what is this? This is D0. This is the least significant digit. Okay, and then we take the 128 divided by 16, we get a 0, right? Not a 0, I'm sorry, an 8 with a remainder of 0. So this is my D1, right?
Yes.
And then we take the 8 and divide it by 16, we get a 0 with a remainder of 8. So this is my D2. That's it. That's the answer here. Okay? So you say, well, D0 is equal to 1, and D1 is equal to 0, and D2 is equal to 8. How can you verify this?
Substitute.
Yeah, exactly. See if the left-hand side equals the right-hand side. So we have D0, which is 1, plus 0, plus what? 256 times 8. This must be equal to 2049. Just do it yourself and you'll see that. Okay? All right. Any question? Okay. So no questions. I'll just erase it so that I can distribute it. Distribute the. By the way, this is an exam, a 191 exam. Okay, and it is available. The key solution is available as well. Okay. But you can watch the video if you'd like to see the solution, how we arrived at the solution. Okay. So now we move to another subject, which is conversion from binary to octal or hexadecimal and vice versa. The most important fact in this conversion is that you have to keep in mind that every octal digit corresponds exactly to 3 bits. And the reason for that is that the base of the octal, which is 8, is equal to 2, which is the base of the decimal, to the 3. Okay? So every 3-bit corresponds to 1 octal digit. Okay? And in case of hexadecimal, every hex digit corresponds to 4, exactly 4 bits. Okay? So these two facts will guide you to the or through the conversion process. Okay. All right. So let's take an example. Here we would like to convert this number into octal. Okay, which is a binary. We would like to convert it to octal. So we start what? Grouping the bits by 3, because we know that every 3-bit is 1 octal digit. Okay, we start the process starting from the radix point, and then group every 3-bit together this side and every 3-bit together this side. Okay, to the left and right of the radix point. Okay. All right. So now we get this grouping. So here we get the 100. You see that 100. All right. And then followed by I'm sorry, it was 110. Okay, not 100. The second one is 100. 100, you see that? And the third one is 010. 010. Okay. And then we have a 1 here. Okay, but we must make it 3 bits in order to fit into the digits. Okay, an octal digit. Okay. Hold on, it's 100, 110, and then 100, and then 010. Okay, and then 1. Yeah, we have to make in order to make the example correct, we have to add a 0 here. Okay. All right. Yeah. Yeah, let me add it to the red color. Okay, so that you know it is a correction. So then finally we have a 10, which is this 10 here. Okay, but we need to add a 0 to the left, which doesn't change the value. Okay, it's just for padding purposes to make it 3-bit. Okay, you got that? And then we do the same for the fraction part. Okay, so we have 0, 1, and then we have to add a 0 to the fraction part, which doesn't change the value. Okay, to make it 3-bit. So 0, 1, 0. Okay. All right. Okay. So now every group corresponds to a digit. Okay. So this one here corresponds to 010 is a 2, right? You may ask me, how do I know? Because I memorized the first 15 binary numbers. Okay. You have to memorize them yourself as well. Okay. Because this will make your life much easier when doing problems in number systems. Okay. 110 is equivalent to 6. Okay. Octal 6 or decimal 6, both the same. Okay. 100 is 4, and then 010 is 2, and 010 is 2 finally. So the octal number is 2246.2 in octal. Okay. Any question?
Yes, doctor. If we, instead of having the 10 in the beginning, if you left it as 1, could we solve the question by adding 2 zeros before the 1? Like
excellent question. Excellent question. Yes, you should pad. Okay, you should pad the required number of zeros to make it 3-bit. Okay, so if it was a 1, just 1, okay, then you add 2 zeros to the left, because they don't change the value. is still 001 or 01 or 0 or 1, just 1, the same value. However, this is a 3-bit and this is a 2-bit and this is a 1-bit. Okay. So in order to make your life easier, you just make them, split them into 3 bits a group. Okay. And then pad whenever you, but the thing that makes a change here, and it is very important, is the fractional part, which changes. Okay. So you can let me tell you what mistakes students may do. Okay. Students may say, well, this is a 1, okay, in Octal, and this is not a 1, it's wrong. Okay, you have to pad it with a 0 to the right, okay, in order to make it 2 instead of 1. Okay, you got that?
Yes, understood. Thank you very much.
Yeah. All right, let's continue. Okay, so we would like to convert this octal number to binary now. Okay, now this is the inverse process. Okay, so we take every digit and then expand it to 3 bits. Okay, so this 4 here is converted to 110. Okay, I'm sorry, it's 100, and then this 3 is 0011. Okay, and then the decimal point, the binary point. Okay, and then the 5 is 101, and then the 1 is 001. It's important, very important, that every digit corresponds to 3-bit. You cannot say the 1 is equivalent to 1 and ignore the left bits, the left 2 zeros. Okay, it has to be 2 zeros in order for the result to be correct, unless it is the most significant digit in the binary, in the octal number. Okay, if it is the most significant bit, the most significant digit, then you can ignore the leftmost zeros. Fine. Okay, but if it is not, then they add a great value to the number. Okay, so this 1 corresponds to 001, and then this 7 corresponds to 111, and then you just concatenate these 3 bits together. Okay, and then you get your number. Notice here that after the binary point, we have 011 and then 100, but we omitted the 00 here from the result because it doesn't change the value. Okay. Okay. All right. So this is the answer here. Okay. Answer. All right. Final answer. The final example is to convert between hexadecimal to octal. Who can tell me how to do that? The most efficient way of doing this.
The octal to binary, and then to hexadecimal.
So it is already hexadecimal. You would like to convert it to octal. So you're suggesting to convert the hexadecimal to binary first, and
Yes.
then convert the binary to octal. Excellent. This is an excellent suggestion. However, you can do it another way, which is a very inefficient way. Okay, you can convert the hexadecimal to decimal and then convert the decimal to octal. Okay, but this is not necessary here. Okay, the conversion to binary is much easier. So hexadecimal to binary, every hexadecimal digit corresponds to 4 binary bits. Okay, so the C corresponds to 1100, and then the 1 corresponds to 0001, and then the hexadecimal point is converted to a binary point, and then 2 is 0010, and then the 8 is 1000. Okay, then all you need to do is to regroup the bits into 3 rather than 4. Okay, so it is basically you have this group 010, and then 000, and then 0. Actually, it's 10, but you have to pad a 0 to the left. Okay, in order to make it 3 bits. And then here we have a 000, and then 1, 111, and then 000. Okay, you add the 0 at the end. Okay. All right. So now we are ready to convert to octal. Okay, so this 0 corresponds to a 0, 0, 0, 0 is a 0, and then this is a 7, and then this is a 0, 2, 0, 2. Okay, so this is the answer. Final answer is 82.1c in hexadecimal is equal to 202.07 in octal. Okay. All right. Now, here are some tips to help you boost the performance of your problem solving in number systems. You should memorize, as I told you earlier, you should memorize the conversion between binary, decimal, octal, and hexadecimal for the first 15 integers or 16 integers from 0 to 15. Okay. So you should construct a table and make sure that you master it. Okay. All right. So make sure that you really memorize. So if I tell you what is this number, you should say 10 exactly. Okay. In binary, this is its equivalent in decimal is 10. Its equivalent in hexadecimal is A, and actually in octal you should memorize only from 0 to 7, not from 0 to 15. Okay. So, but in hexadecimal, you should memorize from 0 to 15, okay? If I tell you what is this, then you should say 13, exactly, okay? It's immediately, you should answer this is 13 in decimal, okay? So without any hesitation. This will help you solve the exams more efficiently, okay? All right, now we move to the next subject, which is important properties of these number systems. Okay, so if I tell you what is the decimal equivalent of the largest integer composed of n digits in base r. Okay, the answer to this question is r to the n minus 1. You don't have to go over the conversion algorithm. It has a shortcut. For example, if I tell you what is the value of f in hexadecimal. This is the largest number in hexadecimal of 3 digits. Okay, then you immediately should say its value in decimal is what? 16 to the 3 minus 1 immediately. Okay, this is one properties of number systems. Okay, the other property is that if you have a fraction, the largest fraction of m digits in base r has a decimal value of 1 minus r to the minus m. Okay, so if I tell you what is the value of 0.77 in octal, what is the value of in decimal of this number? You should say immediately it's 1 minus 2 to the minus, not 2, it's 1 minus 8 to the minus 2. Okay, you get that? It's important to understand these two properties. You can derive them immediately from the conversion formula for from any base to decimal, which is this formula here.
Doctor, I didn't understand.
Come again?
I didn't understand.
It doesn't. There is. So what is? If I tell you what is the let me add a new page here. So if I tell you what is the decimal equivalent of this number here, how can you convert it to to decimal? You use the conversion formula, right? Which is
Yes.
the summation of 15 times what? R to the I. R is 16 here to the I, and I goes from 0 to 3, right? And minus 1. Okay? 15 is a constant, so it's 15 into I 16 to the I, but 16 to the I, 16 to the 3 is a big number. I don't want to memorize that. There is a shortcut for this. Okay, there is a shortcut. Since this is the largest number you can represent in hexadecimal for 4 digits, the shortcut says it's 2 to the number of digits minus 1. I'm sorry, not 2. It's the base, which is 16 to the number of digits minus 1. This is the decimal equivalent of this number. And you don't have to go over the conversion process. Okay, there is a shortcut. This is the property. What does it mean? Okay, the largest number that you can represent in hexadecimal with 4 digits. Okay, it's FFFF. Okay, what if I ask you what is the largest number that you can represent in octal with let's say 5 digits?
777.
Yeah, it's 5 sevens basically. Okay, and what is the value of this number in decimal using the shortcut? It's 8 to the 5 minus 1 immediately without thinking. Okay,
Okay.
now if it is a fraction, there is another shortcut, which is what? If there is an FFF here, okay, 16, it's equal to 1 minus 16 to the number of fraction digits, but with a minus sign. Okay, you get that? So this is what it means. Okay, so instead of converting it the normal way, which is using this summation here, okay, you can immediately calculate it this way. Okay, this is a number system property that you can prove, by the way, easily using this conversion algorithm. Okay, but we don't have time to prove it. Is it clear now?
Yes, clear. So
Okay.
it's only valid for the biggest number.
Exactly, it's the largest integer. It's written here. Okay. All right. So if you have n integer digits and m fractional digits, then the maximum in base r is equal to r to the n minus r to the minus m. It's just the sum of the two cases. If you add these up, you get r to the n minus r to the minus m. Okay. So another important property of number systems is what is the result of adding 1 to the maximum integer in base r, okay, of n digits. Okay, let's take the decimal example. Let me write it here. Okay. So if you add 1 to 999, what is the result? It's 1000, right? If you add 1 to 9999, it's going to be 1 followed by 4 zeros, right? Again, this is in decimal. In any other base, it's the same. It's exactly the same. So if this number is the largest, for example, in hexadecimal, okay? Hexadecimal. If you add 1 to it, then it will be 1 followed by 3 zeros, okay, in hexadecimal. Okay? This is exactly the same as, so if you convert this to decimal and convert this to decimal, which is what? As we learned from the first property, it's 16 to the 3 minus 1, right? And if you add 1 to it, you get what? 16 to the 3, right? And how do you convert this to decimal? It's 0 times 16 to the 0 plus 0 times 16 to the 1 plus 0 times 16 to the 2 plus 0 times plus 1 times 16 to the 3, right? Which is equal to this one. Okay, so these are equal to each other. Okay, do you get that? So let me ask you this, if you have got it. Let me ask you this. What is 5, 5, 5, 5, 6 plus 1. I want to answer in base 6.
One followed by
4 zeros.
Excellent. 1 followed by 4 zeros. But it's in base 6. Notice that this is not the case in decimal. The case in decimal is going to be what? Is going to be 6 to the 4. Okay? This is the value of this number. Okay? So whatever that value is, it's going to be that. But in base 6, it's represented as this. Okay? So this is the result of adding 1. And you can see that from using the first property. Using the first property, we know that if f in 16 is equal to 16 to the 4 minus 1, and if you add 1 to both sides, you get what? You get a plus 1 here, and you get a minus 1 plus 1 here. So the minus 1 cancels here. So it's 16 to the 4. Okay? All right. So in general, if you have a number, the maximum number of n digits in base R, which is represented this way, okay, plus 1, then the answer in decimal is going to be R to the n, and the in base R, it's going to be 1 followed by how many zeros? In base R, they are n zeros, okay, n zeros. All right, because we have here n digits. Okay, do you get that? So this is the here is another property. How many integers are there using n digits in base R? Okay, so you can list them. Okay, the first integer is 0, second is 1, third is 2, all the way to the maximum number that you can represent, which is this number here. Just a concatenation of the maximum digit in base R of n digits. Okay, so since we started from 0, the answer is going to be the largest number plus 1, right? So the largest number, as we saw, is R to the n minus 1 using the first property that we learned. And if you add 1 to that, the answer is going to be R to the n. So the number of how many integers can you represent using n digits in base R is R to the n, basically. Okay? Any question? The material has finished today. Okay, and let me before we conclude, let me ask you if you have any questions. By the way, we have studied a lot of material, so please go back to the lectures and try to what we call digest the material by solving as many problems as you can, and by watching the videos. Okay, don't think that the presentation. Don't be fooled by the presentation. Okay. The material is not easy. Okay, so go back and try for yourself. Okay, so any question? No questions are there. I'm going to stop the presentation, stop the recording.
So, doctor, is the calculators allowed in the exams?
No calculators are allowed.
Okay.
You have to be skillful using your arithmetic. Okay.